experimental verification of principle of superposition for a given cantilever beam. Let us take a cantilever beam, okay? So of length, total length from the fixed to the tip is 500 millimeter, and the width is 16 millimeter, and the thickness or depth is 6 millimeter. So it is made up of mild steel. The cantilever beam is made up of mild steel. Okay, so let us mark some 3 points randomly on a cantilever beam. Let us take this as a point 1, and this point as 2, and a point where the dial gauge is fixed. Let us take it as a point O. Okay, so we'll add a weight at point 1. We measure the deflection. And here we add a weight and measure the deflection at point O. So here, when the weight is added at point 1, it's nothing but delta 1. It's a deflection due to weight at point 1. Okay, and here, when you add a weight here, the dial gauge gives you the deflection due to weight at point 2. Now here, we add weights simultaneously on point 1 and 2. So the dial gauge shows the deflection due to weight at point 1 and 2. So what the principle of superposition says, the algebraic sum or the sum of the deflection due to load at point 1 and due to load at point 2 will be equal to the deflection at the same point, reference point O, due to the loads acting at the respective points 1 and 2 simultaneously. So here, this picture gives you the idea for the experiments, how it is performed. So at the end, I have attached the video, how the experiment is being conducted. I have not taken or I have not referred any readings from the video. Video is just for demonstration purposes. Okay, I have not considered any readings from the dial gauge that is shown in the shown during the experimentation. Okay, so this is the apparatus required here. Okay, so as we have seen for a simply supported beam, and these are the dimensions you can enter here, and this is the theory. The principle of superposition simply states that on a linear elastic structure, the combined effect of several loads acting simultaneously is equal to the algebraic sum of the effects of each load acting individually. So delta 1 plus delta 2 is equal to delta 1, 2. So here, the diagrammatic representation. Okay, so this is the, let us go to this figure. Delta 1 is the deflection due to W1 at point 1, and delta 2 is the deflection reference point 2 due to W2 acting at point 2. And this is the delta 1, 2 is the deflection at the reference point due to W1 and W2 acting at point 1 and 2 respectively. So we just add a weight. Here, this tabular column shows that we are adding the weight in the range of 500 grams or 0.5 kg. During loading, we note down the deflection, needle deflection in the dial gauge. Okay, so the weights are added in the order of incremental order of 0.5 kg, 0.5 kg like that. Okay, so till we reach 2.5, the weights are being added, then it is unloaded, then we have taken an average, then it is multiplied by 0.01 to get the value, deflection value in millimeter. Okay, so the video is video shows the deflection for the weight which is added in the range of 100 grams. Okay, 100 grams. So here the reading or tabular column reading shows only for the 500 grams. Okay, so here we add the weight at 0.1. So at 0.2 we add the weight, then loading, unloading, average part, then we just convert that dial gauge reading to millimeter. Now here W1 and W2, 1 kg, 2 kg, 3 kg like that, it is acting simultaneously on point 1 and 2. This is for loading, unloading, average, and average deflection in millimeter. Okay, so we just look into the deflection. For example, delta 1 plus delta 2 should be equal to delta 1, 2 or delta 2 or whatever it is. Okay, nothing wrong in that. So 55 plus 55 is equal to 110 to take the first experiment. So like that, you can check for the other set of readings also, which is very close to the final value that are obtained for delta 1 2 or delta 2 1. Okay, so both are one and the same. Okay, so this is a procedure as I explained earlier. Okay, so it is observed that principle of superposition is proved, okay, experimentally. So let me show the video so that we get more idea. Okay, I'm not following any readings that is shown in the video. Okay, now we can see the setup, experimental setup. Okay, so this is the point 1 and this is the point O. Okay, you can see here, this is the pixel end, point 1, point 2, and point O. Okay, so at point 1, we are going to add the weights. So in this demonstration, we are going to add the weight in the range of 100 grams. Okay, 100 grams. So we measure the deflection. We're not following this dial gauge readings. Okay, so loading part. Again, 100 gram is being added. Again, 100 grams. So total 300 gram weight is acting on the beam. 400 gram. 500 gram. So this is the loading part. Now unloading. Step by step, we remove the load by 100 gram or 0.1 kg. It is recorded under the column of unloading from the bottom. Now we have shifted the weight angle to the point 2. Now 100 gram weight is being added. Measure the deflection at the tip, that is at the reference point O. Then again 100 gram, so totally 200 gram or 0.2 kg. 300 gram. 400 gram. 500 gram. Now loading part is over. Now unloading. We have to remove the weights by 100 grams. Okay, so now we are adding weight. Two weight angles, we are adding the weights simultaneously. Again 100. So totally 600 gram load is acting, that is 0.6 kg. Unloading now. Thank you.